Okay, so we are moving on to the last lesson of this unit. It's not really a lesson because it's just applying the exponent laws that we have already learned. We're just going to put everything together and simplify, okay? And I'm giving you a little bit more complex examples today. Okay, so I am going to, again, quickly going over some of the rules that we've learned so far. So this is the multiplication rule. So x to the power of a times x to the power of b. Recall, when we multiply powers, you add exponents. That means when you divide powers with the same base, again, the key is that you have to have the same base, is then you subtract exponents. You have power to a power. That means you multiply the exponents. You could have to the power of 0, which remember is just always equal to 1. You can have negative exponent, which means you flipped the fraction and becomes 1 over x squared, or take the reciprocal. So these are what we did in the previous years. Yesterday, or last lesson, we had rational exponents. So recall, if you have 1 over 3, this just means it's a cube root of x. Or you could have, let's say, 5 out of 4. This means it's the fourth root of x and then to the power of 5. Okay, or of course, this is the same thing as the fourth root of x to the power of 5. Okay, either or, they are the same thing. Okay, again, when you're evaluating, this would be more useful. Okay, so these are the rules that we've learned so far. We're going to use these rules and apply to the example right here. So I have two examples for you today. Let's take a look. The first one, we have a fraction and then raised to a power. Okay, so I think there's a y missing here. I don't know what happened to it. It disappeared. So we have 32xy to the power of 1/3 divided by 8x squared y to the power of 2/3, and everything to the power of 1/2. So in this case, what I would do is I will simplify whatever that's inside first. That's 32 divided by 8. That is simply a 4. We have x divided by x squared. So there's a trick to this. You could definitely just subtract, right? 1 minus 2 is -1, and you keep the x there. What I would do is I look at the bigger exponent. Okay, the bigger exponent here is 2. It's in the denominator. So in that case, what I'm going to do is I'm actually going to subtract from the denominator. Okay, that means 2 minus 1, which is a 1. And notice how if I subtract from the bigger exponent, well, the exponent remains positive. But you got to keep in mind, if you subtract from the denominator, that means the base stays in the denominator. Okay, if you subtract from the numerator, then the base stays in the numerator. Okay, so now we have, okay, again, there's y here. I don't know what happened to it. Y to the power of 1/3, and that's y to the power of 2/3. Again, 2/3 is bigger than 1/3, so I'm going to write this in the denominator. And 2/3 minus 1/3 is a third, and we still have everything to the power of 1/2. Okay, so again, 4. So this means we have 4 to the power of 1/2. Recall, anything. Exponent of 1/2 means square root. So we are taking the square root of 4. Okay, so again, if the exponent is 1/2, that means we're taking the square root. And the square root of 4 is a 2. So I'm going to write a 2 here. And this is power to the power. So what that means is we're going to multiply the exponents. So 1 times 1/2 is 1/2. We have 1/3 times 1/2. That's 1 over 6. Okay, 1 over 3 times 1 over 2, 1 out of 6. And that is the answer. And again, notice how I kept all the exponents positive for the final answer. Okay, so that's the first example. Next example, this does definitely look way more complicated than the questions we've seen yesterday or last lesson. Okay, so but this is it. Okay, I mean, it's not really a lesson. This is after this example, that's it. Okay, it's just examples today. Okay, so again, same thing. What I would do is I would simplify whatever that's inside the brackets first. Okay, when possible, of course. Sometimes it's not possible to simplify, but that's okay. Like this, 6 out of 5. There's nothing you can do about that. So you know what? Actually, no, that's not what I'm going to do. Okay, I noticed that this exponent is negative. So what I'm going to do instead is I am going to flip the fraction right away. So I'm going to have 5x to the power of 1/3 y to the power of 5 over 6x y cubed. Oh, what happened there? Y cubed squared. Okay, because again the exponent is negative, that means I can turn into a positive exponent as long as I flip the fraction, which I did. Okay, I just moved the numerator and denominator, I just swapped them. Okay, so that's what I did with the first set of brackets. For the second set of brackets, I would need to work with this first, but there's nothing I can do. So then I'm going to apply the cube. You know what? I'm not going to apply the cube either. I have exponent and exponent back to back, right? That's power over power. So what I'm going to do right now is I'm going to multiply the exponents together. Okay, so that's 3 times 5 over 6. This is, you can divide this by 3, divide that by 3, you get 5 out of 2. Okay, so again, that's exponent, exponent back to back. That means I need to multiply them because that's power over power. So I end up with 5 over 2. Okay, so now I'm going to simplify what's inside the first set of brackets. Again, 5 out of 6, absolutely nothing you can do about that. We have x and x as the base, so I'm now going to look at the exponents, see which one is bigger. That's 1 over 3. Recall, if it's not written, it's a 1. 1 is bigger than 1 over 3, so I'm going to subtract from the denominator, okay, because 1 is bigger. 1 minus 1/3 is 2/3. And then we have y as the base here. That's exponent of 5. That's exponent of 3. 5 is bigger, so I'm going to subtract from the numerator. 5 minus 3 is a 2. Square remains as a square. Okay, moving on to this second set of brackets. Okay, now we have 4 to the power of 5 over 2. Now, what I'm going to do is I'm going to rewrite 4 to the power. You know what? One step at a time, okay? One step at a time. I'm not going to skip steps. You could later on, but for now, maybe we should just stick with step by step. Okay, power of power, multiply. Negative 3 times 5 over 2. Again, that's 3 over 1, so negative 15 over 2. For y, we have 1/2 times 5 over 2. That's 5 over 4. Okay. Now I'm going to apply the squared into the brackets. Okay, so then we have 5 squared, which is 25. We have y squared, so again, power of a power, multiply exponents. We have 6 squared, so that's 36. And we have 2/3 times 2. Right? So that's 2 over 1. So that's 2 times 2 is 4. 3 times 1 is 3. So 4 over 3. Now I'm going to turn this 4 to the power of 5 over 2 into the radical because I know I can actually evaluate this, right? Because it's a 2 in a denominator, which means the index is a 2. So it's a square root. And I know square root of 4 is a nice number. Okay, there's nothing I can do with the x and the y. Okay, next I am going to multiply these two things together now, okay? So, well, I guess I can simplify. Well, there's nothing I can simplify here, but I can multiply the y with the y, right? Because that's multiplication. So when you multiply again, you add exponents. So I'm going to add the exponents right now. Maybe I won't do that. I'm going to do it like this. Y to the power of 4, so that's 4 plus 5 over 4. Right? You can change 4 to 16 over 4. Again, when you add fractions, you need to have common denominator. So this is y to the power of 21 over 4. Whereas x, this is actually dividing, right? Because this is in the denominator. This would have been in the numerator. Now, here's the thing. This is negative. So really, what we can do is, you know what, I'm going to make this less complicated by, it's just division, right? Because this is numerator, this is denominator. We look at the exponents, that's positive 4 over 3, that's negative 15 over 2. So clearly 4 over 3 is bigger. So what I'm going to do is I'm going to subtract from the denominator. Okay, so if you think about this, right, that's over 1. So that's the numerator. and that's the denominator. This is bigger, so I'm going to subtract from the denominator. So I'm going to erase this for now. Y to the power of 21 over 4 over x. So if I subtract from the denominator, then that means I have 4 over 3 minus negative 15 over 2. I need common denominator. This time is going to be a 6. So that's going to be an 8 times everything by 2. We have minus, so that's actually a plus. To turn out into a 3, we need to multiply by 3. 15 times 3 is 45. 8 plus 45 is 53. So 53 over 6. So that's our exponent, 53 out of 6. Finally, we have this right here. That's square root of 4, which is 2. And 2 to the power of 5. Again, that means 2 times 2, 5 times. That's going to give us 32. Okay, we're almost done. We can simplify this. Again, recall 32 is something as 32 over 1. We can divide 32 by 4. We can divide 36 also by 4. We get a 9. So then we end up with 25 times 8, which is 200. Y to the power of 21 over 4 divided by 9 is just going to be 9. X to the power of 53 over 6. Okay, and that is your final answer. Okay, so you can see this second example is, well, quite a bit more complex than any questions that we worked before. So I would suggest you, if I lost you, okay, so make sure you go back, watch it at half speed, or you pause the video and yeah, try it again, okay? I don't think I'll give you any more questions or any questions more challenging than this, okay? This probably is the most kind of complex questions you'll see. Okay, so that's it for this lesson. It's not a real lesson. It's just showing you examples on how you can apply your exponent laws. Okay, and that's the end of this unit.